Okay, so we want to find the sum of these 5 numbers, but we don't know how. I mean, of course, you could just bash through the entire thing, noticing that 12 plus 48 is 60 and 6 plus 24 is 30, and that makes it really convenient, and eventually you'll find that the sum is 93. But what if this went on for really long? So we notice that this is always multiplying by 2, 2, 2. And what if you had like 100 of these terms and you have to find the sum of all of them? Well, you're lucky because the thing is, this is just something called a geometric series. You multiply each term by 2 to get the next term, and so on. Except geometric series can be multiplied by anything. For example, 3. You could do 3, you could do 4, and there could be any number. It doesn't really matter. So, we're going to solve for this algebraically. And what we're going to do is call this whole thing S. And S is equal to this whole thing. So, what happens if we multiply S by 2, which is the increasing factor in our geometric series? Then we get 2S equals this entire thing. And we notice that a lot of these terms are the same as the terms in the original geometric series we had. And this is just a new geometric series. So, let's subtract them and see what happens. When we subtract, we get 3 minus 96 equals S minus 2S. And if we solve for S, we actually end up getting that S equals 93, as expected. So, we can apply this generally. So, if we have something that we're multiplying, let's say by D over and over again, how will we find the sum of that? So here's a generalized example, and we've set our sum of our geometric series equal to S. And the number that we're multiplying is R, so we see that A times R is AR, AR times R equals AR squared, and so on all the way up to AR to the nth. So that means we have n plus 1 terms in total. So again, let's see what happens when we multiply the whole thing by the common factor, or R. And we get that this is what SR is equal to. So, again, we see a lot of the current terms we have are in common with this other geometric series that we just made. So, we can again subtract them, and we'll get that A minus AR to the n plus 1 equals S minus SR. And we can factor the S out, and we'll get that this equals S times 1 minus R. And then we can solve for S. This equals this. And then we solve for S, and eventually we get that S equals A times 1 minus R to the n plus 1 all over 1 minus R. So again, it's a very neat formula. It's neat also like the arithmetic formula, which is also a very neat formula. And if you haven't seen the arithmetic formula video, then I suggest that you go check it out, because if you learn about arithmetic series first, that is generally better instead of learning about geometric series first. But anyways, thanks for watching. I hope you enjoyed, and remember to like and subscribe.